So this is the 50th video on Newton's laws of motion. This is in continuation of the 49th video. In this video also I will take up a numerical problem on Newton's laws of motion, in which the concept of combined equation, constraint theory and pseudo force will be used. First I draw the diagram of the situation. See, this is a smooth horizontal surface. This is a wedge of mass 4m. Side view is shown. This is the inclined face of the wedge, which makes an angle of 30 degree with the horizontal. Here there is a fixed rod support. From this massless pulley has been attached, smooth massless pulley. This is a string. Here we have a block of mass m. And here we have a block of mass 2m. This is a string. This string is massless and inextensible. Pulley is light and smooth, and there is no friction anywhere. Okay. There is no friction anywhere. The string is massless and inextensible. Okay. And this is the fixed rigid support attached to the wedge. Here we have a massless pulley. Okay. Now question is find the acceleration of wedge W with respect to ground after the system is released from rest. Okay, fine. So this is the wedge W. This block of mass m we call it, say, as B1. This is a block of mass 2m which we call as B2. Okay. And this string is parallel, both these string segments are parallel to the inclined surface of the wedge. So this is the question. Okay, fine. So first of all, what you have to do, you have to show the acceleration of wedge with respect to ground. So acceleration of wedge W with respect to ground will be equal to A rightward direction, A say. These two blocks will move with respect to wedge. Let us assume that the acceleration of block B1 with respect to wedge is B up the incline. And since this is a larger mass, so with respect to wedge, this is a downward acceleration of C with respect to wedge. So AWG meaning acceleration of wedge with respect to ground, that is simply A B1W, acceleration of block B1 with respect to wedge, that has been assumed B in up the incline, and A B2W meaning acceleration of block B2 with respect to wedge, that is C in down the incline. Here B and C will be equal, but to demonstrate the various aspects of constraint theory, I have taken them to a different. But from constraint theory we will prove that they are indeed equal. Okay. One more thing, the string is massless and there is no friction between string and pulley in contact anywhere. So tension at all points of the string is same, equal to say T. Tension at all points of string is same, say equal to what? T. Alright, fine. Now what we will do first, we will apply the Newton's second law of motion to blocks B1 and B2 with respect to wedge. And then I will write down the combined equation of motion of entire system, wedge plus two blocks plus string plus pulley in rightward direction. Fine, alright. First what I do, I draw the free body of B1 and B2 with respect to wedge. I draw the free body of B1 first. This is the block B1. So what are the real forces acting on it? Mg, tension T pulling it up the incline, a normal force N1 acting on block due to wedge. Now this wedge is a translating non-inertial reference frame. So if you view the block B1 from wedge, then pseudo force will also act on it. It will be opposite in direction to A, and its magnitude will be Ma. So this is the free body of block B1 with respect to wedge. Okay, fine. This is the free body of block B1 with respect to the wedge. Now apply Newton's second law to this block B1 with respect to wedge up the incline. So what do I write? T minus mg sin 30 degree, that is T minus mg by 2 minus ma cos 30 degree is equal to MB. This is the first equation. Okay. Now what I do, I draw the free body of B2 with respect to wedge. So free body of B2 with respect to wedge will be something like this. 2mg T N2 and a pseudo force acts on it 2ma leftward because wedge is a translating non-inertial frame. 2ma. Alright. Now I write down the Newton's second law equation of 2m with respect to wedge down the incline. So what do we get? We get 2ma cos 30 degree root 3 by 2 plus 2mg sin 30 degree. 2mg into half minus t is equal to 2mc. This is the second equation. Alright, fine. That is just equal to how much? 2mc. So we get 2ma root 3 by 2 plus 2mg sin 30 degree minus t is equal to 2mc. Now what I do, I write down the combined equation of motion of m, 2m and 4m in rightward direction. Now as I have stated several times in the previous videos, combined equation is always written with respect to ground in a particular direction. In combined equation of motion, only real external forces appear. There are no pseudo forces at all, and no internal forces appear. Only real external forces that appear in the combined equation of motion. So first we have to draw the free body of, write down the combined equation of 4m, m and 2m in rightward direction. I will draw the respective free bodies of this and this with respect to ground. Okay. This one is okay, fine. So I draw the free body of all these three bodies with respect to ground. Okay. So I draw the free body of B1, B2 first. Here free body of B2 was drawn with respect to wedge. Here I am drawing its free body with respect to ground. Okay, fine. I draw the free body of B1 with respect to ground. T, Ng and N1. Okay. Now I draw the free body of 4m, pulley, rod and this considered together as a system. So here we have 4mg, here we have N3, here we have N1, here we have N2, third law. Now what else? Pulley is considered to be part of the wedge. Pulley is considered to be the part of the wedge. Okay. Rod is also considered to be the part of the wedge. And what else? Pulley is taken to be part. So I'll draw the pulley here. So half portion of the pulley is in contact with the string. So string will effectively exert force on the pulley at 2 points, at this point and this point. T down and T down, like this. Pulley has been considered to be the part of the wedge itself. So T and T, so this is the net force on the pulley due to string in contact with it. As I mentioned just now, half portion of the pulley is in contact with the string. The string exerts normal contact force on half portion of the pulley. Resultant of these two will be T and T acting at these 2 points of the pulley. Okay, fine. So equivalently we will say that this string exerts force on the pulley at only 2 points, at this point and this point. T in this way, T in this way. So they have drawn it here. These are the respective free bodies of B1, B2 and wedge with respect to ground. Now, what are the internal forces on this system? This T and T, they are internal force, they go away. N1, N2, they are all internal forces, they go away. T and T, they are all internal forces, they go away. So what are the only external forces? 4mg, N3, mg, 2mg. That's all. So on the entire system, net external force on the system in this direction is 0. Okay, because external forces are this and this, that's all. So all the external forces on the system in vertical direction. There is no external force on the entire system in rightward direction. They have 0 component. Okay, so the force will be 0. That is equals to 4ma. plus now what do we have right here? Mass times m, block of mass m b1, times acceleration of block b1 with respect to ground in this direction. Let us call this direction as x direction. What do we write here? X component of acceleration of block b1 with respect to ground. So m a b1g x component. Okay, fine. Plus 2m times acceleration of block b2 with respect to ground in this direction, that is along xy direction. We write as x component of acceleration of block b2 with respect to ground. Okay, fine. From the theory of combined equation of motion. In case you have any doubt regarding combined equation, you go to the 19th video on Newton's laws of motion. You will get all the details there. Okay, the playlist has been made. You go to the playlist and search. You will get all the details. Okay. Now m will go away. You can see. So we get 0 is equal to 4a plus a b1gx, that will be written as a dot product a b1g dot I hat, where I hat is a unit vector along x axis, plus 2 times a b2g dot I hat. I hat is a unit vector along x axis. Alright, fine. Now rub this one. So we write 0 is equal to 4a plus a b1g dot I. Now a b1g will be written as, from the formula for translating frame, a b1w plus a wg dot I hat plus 2 times a b2g, that will be written as a b2w plus a wg dot I hat, adds up to 0. A b1w is what? Vector b. Vector b plus awg is vector a dot I hat plus 2 times a b2w is acceleration of block b2 with respect to wedge, that is c, vector c, and this is vector a awg dot I hat. Alright, so 0 is equal to 4a plus this becomes b dot I hat plus a dot I hat, 2c dot I hat plus 2a dot I hat. Alright, fine. Now what I'll do, I'll put up this one, okay? So what do we get here? 0 is equal to 4a b dot I. B is in this way, I hat is this way. This becomes b into 1 into cos 30 degree. That is b root 3 by 2. Okay. Now what about this a dot I? A dot I is a into 1 into cos 0 degree. That is simply a. Plus 2c dot I. C is in this way, I is that direction. C dot I becomes 2 times. 2 is here. C dot I hat. C into 1 into cos 150 degree minus root 3 by 2. Because angle between C and A is 130 degree. C and I hat. Plus 2a I dot I hat. That becomes 2a. 2 into a into 1 into cos 0 degree. Alright. How much this becomes? 0 is equal to 4a plus a plus 2a. How much that becomes? 7a. 7a plus b root 3 by 2 minus c root 3 is equal to 0. This is the third equation. Okay. Third equation is this one. 7a, 2 times 0 I have written twice by mistake. So 7a plus b root 3 by 2 minus c root 3 is equal to what? 0. The 7a plus b root 3 by 2 minus c root 3 is just equal to 0. This is the third equation. Alright. Now we have to write down the constraint equation. See how many unknowns are there? A, B, C and T. 4 unknowns are there. And we have written down 3 equations. We need one more equation. Now for that we have to find the relation between A, B and C. So what do? We write down the constraint equation for the system. Okay. Now rub this one. Now constraint equation can be written in ground frame also and it will be written in wedge frame also. In both the frames you can write down the constraint equation. So what I'll do, find the constraint equation by both the methods. Okay, I'll write down the constraint equation by both the methods. I'll write down. First, for that, let us assume some data. Assume that this wedge undergoes a displacement of say dx with respect to ground in time t to t plus dt. Suppose with respect to this wedge, this block B1 undergoes a displacement of say dl1 with respect to wedge. And the block of mass 2m, suppose it undergoes a displacement of dl2 with respect to wedge. So dx is the displacement of wedge with respect to ground in this time interval. dl1 is the displacement of block B1 with respect to wedge in the same time interval of the incline. And dl2 is the displacement of 2m with respect to wedge down the incline, dl2 with respect to wedge. Okay. Now you have to apply the constraint theory. Work done by string on all the bodies in contact with it adds up to 0 in any frame of reference. Work done by string on all bodies in contact with it adds up to 0 in any frame of reference. So consider this string. This string is attached to this block B2 of mass 2m here. Then this string passes over this pulley. As I just now said sometime previously in this video itself, string effectively exerts a force on this pulley at 2 points, at this point and this point, P and T. And then this string is attached to block of mass m. It exerts force on this block also. So in all, we have to consider 4 points as far as work done by string on all bodies in contact with it is concerned. So from this point, T acts in this way, and displacement of this with respect to wedge is dl2 downward. So I'll write down the constraint equation in ground frame. Okay. So constraint equation in ground frame. So while writing on the constraint equation in ground frame, all the displacements of the bodies concerned have to be taken with respect to ground frame. Displacements of all the bodies concerned have to be taken with respect to the ground frame. Okay. So let us take this point first, 2m. Or we take from here. So what do we write in this? T dot displacement of block B1 with respect to ground. Let's call it say dB1G. Displacement of block B1 with respect to ground. Okay. Plus on this pulley. On this pulley effectively force acts at this point and this point. 2T. And displacement of this pulley with respect to ground is simply that of wedge with respect to ground, dx. So how do you write that? 2T dot displacement of this pulley with respect to ground, dpg. P for pulley, G for ground. Plus work done by string on the block of mass 2m, B2. So we write T dot dB2G adds up to what? 0. Fine. Now what dB1G, what do we write? That will written as displacement of block B1 with respect to wedge plus displacement of wedge with respect to ground. Okay. Plus 2T dot dPG, displacement of pulley with respect to ground. That is just the displacement of wedge with respect to ground, because the pulley is rigidly fixed to the wedge. So this becomes 2 dot dx plus T dot dB2G. T dot what? dB2G. So that becomes T dot dB2W plus TWG. Okay. Adds up to how much? 0. Fine. Alright. Now add up all these things. Okay. So write this equation here. So 7a plus b root 3 by 2 minus 2c root 3 minus c root 3 is 0. This is the third equation I have written here. Alright. This are a bit, okay. I'll simplify this here. So this becomes T dot dB1W, acceleration of block B, displacement of block B1 with respect to wedge, that is dL1, plus dWg dx, vector dx, plus 2t dot dx, plus t dot, what is dB2W? That is nothing but vector dL2, displacement of block B2 with respect to wedge, that simply becomes vector dL2, plus displacement of wedge with respect to ground, simply dx, that is adds up to 0. Now this we evaluate this t dot dl1. On this t acts in this way, dl1 in this way. So t dot dl, and let first I'll simplify. T dot dl1 plus t dot dx plus 2t dot dx plus t dot dl2 plus t dot dx is 0. Now what about t dot dl1? T is in this way, dl1 is in the same direction. This becomes t into dl1 into cos 0 degree. Cos 0 degree becomes 1. Now t dot dx. Now this t dot dx is here. T is here, dx is that way. So t and dx angle is 30 degree. This becomes how much? T into dx into cos 30 degree, root 3 by 2. Okay. Now this 2t dot dx. On this 2t, t and t is in this way, dx is that way. Angle is 150 degree. So this becomes 2t into dx into cos 150 degree minus root 3 by 2. Alright. Now t dot dl2. On t is in this way, on this, and dl2 is here, angle 180 degree. So this becomes how much? T into dl2 into cos 180 degree, which is minus 1, plus t dot dx. T dot dx on which one? This one. T is in this way, dx is in that way. That becomes t dx cos 30 degree. T dx root 3 by 2 adds up to how much? 0. Alright, fine. See, one thing I would like to say. This t and this t, they are not the same, but I have used the same notation. This t means t acting on this m, which is in this way, and this t means t acting on this pulley, which is t and t in this way, and this t means t acting on this block of mass 2m, which t is in this way. So these t's are not the same, but same symbol I have used. Okay, but these t's have different meaning. Okay. So now I'll rub this fine. Now what do we get? T dl1 plus t dx root 3 by 2 minus 2t dx root 3 by 2 plus minus t dl2 minus what? Plus t dx root 3 by 2, last term here, adds up to 0. Now this and this, they go away. So we get t dl1, t dl2 0. T and t cancel out. dl1 dl2 0. dl1 is just equal to what? dl2. This meaning, now in the problem there are no variable angles. So constraint relation for displacement and constraint relation for acceleration are same. So to find the relation between B and C, we replace dl1 and dl2 by corresponding accelerations. So for dl1 we take B. So we write B equal to what? C. This is the fourth equation, which is the constraint relation. So this is the fourth equation, I'll write it here. B equal to C. This is the fourth constraint relation. Fourth equation, there is a constraint relation between B and C. So see, we have obtained a constraint equation in ground frame. It was quite lengthy. Now we can simplify this. Now what I'll do, I'll write down the constraint equation in wedge frame. That will be much more easier. I'll rub this one, okay? Now constraint equation in wedge frame. So in this sum of work done by string on all bodies in wedge frame adds up to 0. So again you have to consider this 4 points of this string. This string exerts pulley. This string exerts force at 4 points. First, it acts at the force at this point. It acts on block B1 at this point. It acts on pulley at effectively 2 points, this point and this point, T and T. And on this, it acts T in this way. So 4 points we have to take. Now we are acting on the constraint equation in wedge frame. So all displacements have to be taken with respect to wedge frame. First, we start from here. So T acts in this way, and displacement of M with respect to wedge is dl1 in that way, same direction. So what is the work done by T on this? T dl1 cos 0 degree. Cos 0 degree becomes 1. Now these two string acts on pulley at effectively 2 points, at this point, T here. And with respect to wedge, it is motionless. So work done with string becomes T into 0 plus T into 0. Because with respect to wedge, it has 0 displacement. Plus on this one, T acts in this way, and displacement of 2m with respect to wedge is dl2 down the incline. So this becomes T into dl2 into cos 180 degree, which is minus 1. They both add up to how much? 0. So now you see this two, that is 0. So T dl1 minus T dl2 is 0. So dl1 is equal to dl2, which implies B is equal to C. So see, the same constraint equation wedge frame has been simplified so much. It has been greatly simplified, you can see it. So constraint equation wedge frame is again B equal to C. Same equation we have obtained again. Now we simply have to solve these equations to get the required answer. Now we have to determine the value of A. So B and C are equal. So wherever C appears, I will replace it by B. Okay. So from this third equation we see, if we replace C by B from this fourth equation, this one, how much do we get? 7A plus B root 3 by 2 minus B root 3 is 0. So 7A becomes B root 3 by 2. So B becomes 14A by root 3. This becomes B. Okay, fine, alright. Now what I'll do, first equation I've already written there, and second equation also, I'll replace C by B in second equation. So what do we get? 2ma root 3 by 2, ma root 3 plus 2mg by 2, mg minus t barabar 2mb. Okay, fine. And this is the first equation, this equation. Let us call this as say fifth equation. Say. Now what I do, I add the first and the fifth equation. If we add the first and fifth equation, we have to remove B also. No, okay, fine. Okay. So we add the first and the fifth equation and use this data B. So from that B will go away. So we add the first and fifth equation. First plus fifth equation meaning what? T and T will go away. Ma root 3 plus mg minus mg by 2. Ma root 3 plus mg minus mg by 2. Tt goes away. And then what else? Minus ma root 3 by 2. I hope it is alright. No calculation mistake, I suppose. It becomes how much? Ma root 3 plus mg minus mg by 2. Ma root 3 plus mg, okay, minus mg by 2, okay, minus ma root 3 by 2, okay, is equal to 2mb plus mb, 3m. And b is 14a by root 3. 14a by what? Root 3. Okay, now this can be solved easily for a. I rub this one, fine. So now, in this equation we can eliminate m. M is a common term. So what do we get? A root 3 plus g minus g by 2 becomes simply g by 2 minus a root 3 by 2. Okay, that is equals to 42a by root 3. Okay, fine. Now I'll replace a that side. A common becomes what? 42 by root 3. Root 3 by 2 minus root 3. Okay. G by 2 A. This becomes 14 root 3 minus root 3 by 2. Okay, this one. Okay, fine. I love this one. Fine. So what do we get here? G by 2 is equal to, this becomes 27 root 3a by 2. So 2 and 2 cancels out. So a becomes G by 27 root 3 is therefore the required answer. Okay. This, if you want, you can multiply up and down by root 3. So this can be written as G root 3 by 81. Okay. G root 3 by 81 also we can write. ANS. Okay. ANS meaning answer. Okay. Fine. So see again, a constraint equation theory I have used. You can see the power of the constraint theory. Setting on the equation wedge frame is much more easier as compared to setting in ground frame. It greatly simplifies the computational procedure. Okay, fine. So from this we see that A is equal to G root 3 by 81. This is the value of A. A is equal to G root 3 upon 81. That is therefore the required value of A. Fine, alright. So this I demonstrated in this problem. Okay, alright. Now the next video also I'll take up some more problems. Okay, fine. So this you go through it. If you have any doubt, you write down the comment box. I'll clarify your doubts. Fine. Now I close it here.